Hello, my name is Christian Rosso. I'm a fourth year heading into this new school year at UCSB. My major is data science statistics. I'm also a Central Coast Data Science Fellow. The two courses I am excited for next year are the data science capstone, since I already took that course, and also intro to data science, since I have much knowledge of data science. And the reason I am excited to be undergraduate learning assistant is because I am able to share my experience and techniques and knowledge of machine learning and data science. And also I love collaborating with other students. That's why I'm excited to be a undergraduate learning assistant. So I would like to go into today's lesson. So I will now share my screen. And today's lesson that I would like to talk about is clustering. Clustering is a great to use for when we have unsupervised learning. It is most used when we have X instances that have no Y labels. If we did have labels, then we'd be working on a classification method such as logistic regression or something of that. But since we don't have labels, then we would look at is it as an unsupervised learning, and mostly we would go into clustering to find similar instances. So the goals of clustering is to group similar data instances, and by being able to identify similar instances allows us to assign them to a cluster. Clustering can be used for customer segmentation, recommender system, image segmentation, and analogy detection. And based on my past projects, I feel like analogy detection could be something to look for, as just finding the outlier our can improve our model and its performance, such as accuracy. So the packages I use for today are pandas, numpy, matplotlib, and sklearn. And the data set I will be looking at is none other than the famous load iris, the iris data set, such as many professors be using at our school. And so I will load that setup from this syntax. I'm able to use the iris data set, and I put just the data into this one. This is an array. And then I separated the array into two, which is petal length and petal width. And then I already did some more in depth of petal length and petal width. So I wanted to kind of show like a histogram, because I feel like histogram will let you visualize your data more and kind of have an idea of what kind of grouping is going to be. Such as here we have three sets of groups, 1, 2, 3, based on these bins I created. And also for petal length, I created these blend 4, 5, 6, 7, but it's because I did data die head, and I already kind of looked at the range it is. And based on this, we got see a grouping of 3 based on the histogram. So that kind of makes me think like there could probably be a clustering of 3 groups that are similar before I even did a scatter plot, before I even plotted anything. And when I go down, you can see that I plotted our data, such as X would be petal length and Y would be petal width. And from here, we visually can already kind of group it with our eyes. Like it can't help us when we see something, we already want to make a pattern. So based on this, I'm kind of like confident on the histogram length that we will get like a grouping of 3. So today's method for clustering, I would like to do k-means clustering, which is when we assign k-centroids based on the data we have. And from there, we could essentially find a Y prediction and make our own labels, which I will go more in depth. I imported k-means from the sklearn cluster, which is a package. And since I already talked about why I feel like there would be 3 centroids, I would pick k to be equals 3. And based on k-means, I'm able to equal like that. And based on the syntax and a hyperparameter, I did put it to be 3. And random state 42 is just kind of like trying to save it. And then we essentially can already find some labels, since we talked about like this is X data synthesis, but has no Y labels. And it could tell us what kind of species it is, like what kind of species of plant it is. So based on Y predict and k-means fit prediction, we can see that we get these labels here from 1, 0, 2. So that's very helpful, but we don't really want to focus on that. I thought it was something cool to introduce. So more down, based on the k equals 3, I'm able to find the cluster centroids basically what we're gonna surround, how we're gonna divide the groups or make a decision boundary based on the cluster centers that we found based on how many centroids we wanted. And I felt that B was good based on the histogram I created. Now we go more down, I'm about to visually show where the k-mean cluster center is at so we can have an idea how it works. So with the PLT dot scatter, I'm able to show my centroids and the X mark, and the PLT plot just able to show all the data set instances visually. And then I have the labels written so you can understand that too. And then here visually, we could see based on the 3 centroids, it's already kind of making a clustering for us. It already, based on the white prediction, it already labeled that clustering for us. So I didn't do this here, but more in depth. You could, from this, you could go on to make a decision boundaries. And from there, you could say, this is label 0, 1, 2. And then from based on 0, 1, 2, you could find what kind of iris species we have based on the petal length and petal width and the k-means algorithm we just created and everything. So the k-means cluster is really based on the centroids and the data instances you're working, and more understanding of like what kind of analysis your data is looking for. So if you have like X instances and no Y labels, and you kind of want to find the centroids, and you already did some data summary statistics or describing your data before you went in depth, this is a way you could do that. And this is a way I did it based on my past projects. And something that I feel that's like cool to show is knowing when to choose how many k-means, when it's too much or when it's too little or when it's like the right. And now what I will be going more in depth down here, determining the k for k-mean clusters. Here I have 3 examples. I have k1 equals 2, k2 equals 3, and k3 equals 4. In my first one, we could get a k-means inertia of, let me just do something real quick so we get a visual. So we can see that inertia is basically going down, and inertia means how well a model is performing without making some kind of syntax error or just embedding each other. And we essentially want to choose the center which makes the most difference, such as from A to minus B means K1 to K2 from 2 to 3. We have a 73 inertia difference, which is a lot. But once we go to 3 and 4, we have a difference of 21, which isn't so much. So we would rather be at the centroid where there's a great difference, and that embeds us that's the great k-means for the type of data analysis that we have. So we will pick K3 since it has the greatest difference. And that's what all I have today for our lesson on clustering and knowing how to use k-means and the benefits of using k-means. I was trying to make a decision boundary, but I couldn't make it work. So mostly from here, we could definitely make a decision boundaries, and not even using classification, we could already have labels, and from that labels, which make us understand what instances are similar to each other, and that could correlate to a certain species of our iris, which in that gives us more information about our data. So that's all I have for today to present, and thank you for letting me do this. Thank you. Have a nice day.